Hello and welcome in section 3, Boosting Algorithm. In this video, we'll talk about how to use the AdaBoost algorithm. But before we get into that, let's answer the question, what's actually boosting? So boosting is an ensemble technique when you are creating a strong classifier from a series of weak classifiers. And what's weak classifier? And this is a classifier that achieves an accuracy just above the random guess accuracy. So in case of the binary classification problem, this is where we get a slightly better than 50% of accuracy. And here's how the boosting works. So in case of boosting, we build a model on the training dataset. Then we build a second model to correct errors from the first one. And we continue to build those models and those next models and until we get the perfect accuracy or we reach the maximum number of models. Because of course, the more models you build, the more memory you need to actually process them, to train them. So what about AdaBoost? So this is the most commonly used algorithm in binary classification problems. And by default, it uses a single node decision trees, which are a weak classifiers, also called decision stumps. And during the training of AdaBoost in general, AdaBoost focuses on those data features that improves accuracy. And it ignores those that are relatively irrelevant. And the end prediction is actually the combination of those predictions from all those weak classifiers that we've trained along the way. But what's interesting is that each of those predictions, it has a weight assigned to it, to each of them. And this is actually a learned metric during the training. And the higher the weight, the more accurate a weak classifier is. And it matters more in end prediction. So AdaBoost is a quite interesting algorithm when you have all those, predictions from those weak classifiers, but it also trying to figure out which is the most relevant prediction. Maybe not most, but some predictions are more important than other. And we have to mention a few things about the AdaBoost and data preparation for AdaBoost. And AdaBoost is very sensitive to outliers. So those are the out of range values. Also, it's very sensitive to nosing data, those unwanted values that we have, especially in the output. And you can use a variety of techniques to actually deal with those problems. But when you are using relatively clean data set like the one that we are using, you don't have to worry about it. So let's see how we can use that, using as a scikit-learn package. Let's open a terminal. The location of the source directory, depends on where you've downloaded the source code. In my case, this is in desktop, boosting Python section 3, and then source. So let's open a new Jupyter notebook and see how we can use AdaBoost algorithm. And let's create a new notebook by clicking on New, Python 3. And yeah, we can rename our notebook to, this is a section 3, video 1, AB AdaBoost. And the workflow is very similar to the one that we've got in previous videos. We started with importing the necessary function to get our data. So from BP, section 1, video 5, data, import, get data. So this is our main function to, load and actually prepare the data. Then after that, we are using the same workflow, so we're comparing the performance of a single decision tree in our data set to ensemble algorithms. And in this case, we are starting with, importing a single decision tree. So let's do that. We already know that all of those decision trees are located in sklearn tree. So let's import our classifier from there. So this is our single tree. And then let's import the AdaBoost classifier, and it's all located in sklearn ensemble package. So let's use that sklearn ensemble import AdaBoost classifier. So we've got our classifiers, a single tree, and also our boosting algorithm that will be using a specific type of decision tree. Now, the last thing we have to do is we have some way of validating the results from those two models. And let's use, tenfold cross-validation. And to do that, we need to import the cross-val score function. So we can get that from sklearn model underscore selection, import cross-val score. And the last step in the kind of a preparation phase is to set up our random seed number that we'll be using in initializing our classifiers. So we start traditionally with initializing our single decision tree. So we are initializing decision tree classifier, and we just providing random seed to make sure that we can reproduce the results. And then after that, of course, we want to initialize our AdaBoost classifier. So this is our main model. Don't need to again provide the model that we'll be using, because by default, AdaBoost is using the those small decision trees, so we don't need to do that or need to provide the number of models that we want to create using this algorithm. So n estimators 100, this is our value that we've used throughout the examples in this course, and of course random state. Okay, so once we've got our single tree, also our boosting algorithm, AdaBoost algorithm, it's time to feed them or train them on our data. So let's start with single tree. We just train that using feed method using on our data set. We forgot to import our data first. X and Y, we're just using data. Yeah, and now we can actually do the fitting. So we can train our single tree on X and Y. Let's do that the same with the model. So as you can see, we are using the same exact workflow for pretty much every example. Now it's time to validate our models. So we'll do the tenfold cross-validation on our single tree using cross-val score. We need to provide the actual model we want to use for this validation and the data we want to validate that on. Also, number of those folds that we want to validate or use for validation. Okay, let's do the same for our AdaBoost model. Okay, and once we've get that, let's get those metrics from those cross-validation functions. So k-fold. We need to run mean method on k-fold results because we've got a lot of folds, a lot of validations using different kind of slices of data, right? So this is just mean of all those validation. So here we won't have any surprises, 66% of accuracy for our single decision tree. And what about our AdaBoost? Okay, we have 70%, slightly less than usual, but it's still higher than the single tree.